Final mental model, how Terraform actually thinks. For the past lessons, you've learned individual Terraform features, providers, resources, variables, outputs, modules, state, workspaces, lifecycle rules, and policies may appear unrelated, but they all serve one purpose. Terraform is not reading your configuration from top to bottom like a programming language. Terraform is constructing a dependency graph. That graph becomes Terraform's understanding of your infrastructures. Every plan, every apply, every destroy, and every refresh begins with that graph. Once this mental model becomes intuitive, Terraform stops feeling unpredictable. Its decisions become explainable because every action follows the relationships inside the graph. Terraform never deploys HCL directly. Your configuration only describes the infrastructure you want to exist. Terraform parses every block into an internal graph. Arguments become attributes. References become dependency edges. Expressions become evaluated values. After parsing, Terraform no longer reasons about text files. It reasons about the graph created from your declared intent. The configuration is not the infrastructure. It is the description Terraform uses to build one. Terraform discovers execution order through references. When one resource reads another resource attribute, Terraform creates a dependency. No manual execution sequence is necessary. Terraform follows data flow instead of file order. Independent resources execute in parallel. Dependent resources wait until required values exist. The graph determines execution, not the position inside the configuration file. Cloud providers already know what infrastructure exists. Terraform does not continuously scan every resource. State stores Terraform's last known understanding of reality. Planning compares 3 resources simultaneously. Configuration describes the desired infrastructure. State records previously managed infrastructure. The provider reports the current infrastructure. Differences between those 3 sources become the execution plan. Without state, Terraform loses historical continuity. Without continuity, infrastructure cannot be managed safely over time. On submarines, every watchstander assumes the previous watch left equipment in its documented condition. An undocumented valve change forces the incoming watch to question every assumption before restoring normal operations. Infrastructure drift creates the same operational risks. When reality and documentation disagree, engineers spend valuable time rediscovering what changed instead of solving the actual problem. Terraform state exists to preserve operational continuity before changes are made. Terraform never changes infrastructure blindly. Planning predicts what will happen before any API request is made. Provider schemas validate configuration. Expressions are evaluated. Dependencies are resolved. Unknown values remain placeholders until apply. Terraform calculates additions, modifications, replacements, and deletions before changing cloud resources. The plan is not documentation. The plan is Terraform explaining its future decisions. Some values do not exist during planning. Cloud providers generate identifiers only after resources are created. Terraform marks these attributes as unknown. Unknown values continue moving through the dependency graph. Planning completes despite incomplete information. Apply replaces placeholders with actual values after resources exist. Terraform delays evaluation instead of making assumptions. That behavior prevents inconsistent deployments. Terraform itself does not understand AWS. The AWS provider understands AWS. Terraform builds the dependency graph. The provider converts graph operations into AWS API requests. Each resource type maps to specific provider operations. Provider schemas define required arguments, optional arguments, computed values, and validation rules. Terraform remains cloud agnostic because providers perform the translation. Infrastructure sometimes changes outside Terraform. Someone edits a security group in the console. A subnet is deleted manually. An administrator changes a resource outside version control. Terraform refreshes provider information. Differences appear during planning. Terraform calculates the actions required to restore the declared configuration. Drift is not a Terraform failure. It is a disagreement between configuration and reality. Modules do not change Terraform's execution model. They organize configuration into reusable units. Terraform expands module instances into the dependency graph. The graph remains one connected system. Large infrastructure becomes easier to maintain because repeated patterns share identical logic. Modules reduce duplication. They do not create isolated execution environments. Lifecycle rules do not bypass Terraform. They modify how Terraform evaluates graph operations. Terraform still calculates dependencies. Lifecycle arguments change replacement behavior. Some resources are created before existing ones are destroyed. Other attributes can be intentionally ignored. Lifecycle changes execution strategy. It never replaces Terraform's understanding of the graph. People naturally think procedurally. They expect line 1 to execute before line 2. Terraform thinks declaratively. It resolves dependency relationships before execution begins. Beginners often debug the wrong problem. They inspect file order. Terraform is evaluating graph structure. Learning Terraform becomes much easier when you stop asking what runs first and instead ask what depends on what. Experienced Terraform engineers spend less time writing resources. They spend more time defining the desired outcome. A clear destination produces a clear dependency graph. A clear graph produces predictable plans. Predictable plans produce stable infrastructure. The quality of a deployment is determined long before the first apply. It is determined while describing intent. These lessons establish your Terraform foundation. They cannot replace production experience. Real systems introduce conflicting requirements. Organizations introduce governance. Cloud providers introduce new capabilities. Production incidents expose hidden assumptions. Every deployment teaches lessons that documentation cannot. Continue reading plans. Continue reviewing state. Continue questioning dependencies. Infrastructure engineering rewards curiosity more than memorization. When this series began, the goal was never to teach syntax alone. Syntax changes, cloud providers evolve, Terraform itself continues to evolve. Good engineering principles change much more slowly. Understand dependencies, make intentional changes, review before acting. Leave systems easier to understand than you found them. One day you will build infrastructure that someone else inherits. You may never meet that engineer. They may never know your name, but they will know whether your configuration tells the truth. They will know whether your documentation matches reality. They will know whether your plans were carefully reviewed. They will know whether your decisions reduced complexity or created it. That is the lasting responsibility of an infrastructure engineer. Terraform is not the destination. Terraform is one language engineers use to express disciplined operational thinking. If these lessons help you see infrastructure differently than when you began, then they have achieved their purpose. Thank you for investing your time in this series. I hope it taught more than Terraform. I hope it helped you learn how to think like an engineer.